Hello everyone and welcome. This is Professor Thayer with you here today to talk about our second lecture of the mini course, COMP112. So let me go ahead and share my screen and we can get underway. So, you can of course also share, share along with us if you would like to, using the slides from the Moodle page, or if you prefer, you can just watch on the screen right up here. Alrighty, so today we're going to be talking about expressions and values. So bird's eye view, what we'll talk about how to assign and use expressions and values. We'll talk about the Python types, and we'll talk about statements and parsing expressions, which we did touch on a little bit last time. So getting into the expressions and values. Expressions represent data, and you can evaluate the expressions to yield a value. This is probably something that's very familiar to you already from working with a basic 4-function calculator. So for example, you might type in 2 plus 3 and then press the enter button, and you would get the answer 5. So the idea here is the expression is the 2 plus 3. We use some representation of go evaluate this now, like the equals button, and then the result will be displayed on the screen. So we can think about a similar thing in Python. This is what it would look like in Python. You might type, for example, 2 plus 3. That would be your data in the expression form. And then you would press the enter button, and Python will tell you the answer is 5, just like the calculator. So the value is going to be equal to the original data. Just as we saw, 2 plus 3 is equal to 5. The value is going to be expressed in canonical form. You may have encountered canonical form, for example, in grade school when you learn how to do fractions, because of course there's multiple ways you could express the same value, but it could be written a different way. So for example, you could write 1/2 or you could write 3/6. They're equal. So what Python will do is it will express it in the canonical, otherwise known as simplest form, so that we all know, so we all come up with the common answer. Python can evaluate expressions, which makes it very useful for carrying out math calculations. Python in the interactive mode, or the Python interactive interpreter, will interactively evaluate expressions and display the resultant answer on the screen, which is what we have seen Python doing just now. So a simple expression language. Let's think about what we would need in order to work with a very simple programming language. We would need to have integer and float values. We would want to be able to do arithmetic. We'd want to be able to compare numbers. We'd like to have Boolean values, and would also like to have the Boolean logic. Now, if you're a little fuzzy on what these are, don't worry, because we'll see some examples coming right up. So some of the things, integer values. These are the whole number values in the positive and negative direction, including the number 0. We can represent these on the number line. I recall a 0 is neither positive nor negative, and we have the positive integers on the right and the negative integers on the left. We can also have floating point values. These otherwise are known as the decimal numbers. This set can include the integers, but also includes the points in between. So I've shown just a variety of the different number lines which you may have come across in your various studies of math, to give you just a point of reference here, right? So the natural numbers are similar to the integers, but they begin at 1. The integers, as we've just discussed, the rational numbers include the fractions, particularly ones that cannot be expressed to a finite number of decimal points. So they would go on forever and ever. Then the reals are going to include a variety of other expressions and so on, such as the square root and negatives. And we also have the real numbers over here. So the floating point values will essentially allow us to represent any of these which we wish to represent, whereas the integers are a little bit simpler because they don't allow us to represent any decimal component. So our simple expression language should have the capability of expressing a variety of basic operations. In fact, there are 4: addition, subtraction, multiplication, and division. There may be some others that would be of note, and that includes the difference between the floating point division and the floor division. So we'll talk about these in a moment. You may also wish to do exponentiation, which is indicated by the double star, and the remainder, which is indicated by the percent operator. We would also like to be able to talk about comparisons. To do a numeric comparison, we would use equality and inequality. So we can ask if something is equal or not equal, which is given by these symbols here. Notice that when we talk about the greater than and less than, a little thing you can use to remember this is large mouth, large number, small mouth, small number, right? So this is the big side, so this always points to the bigger number. So when you have a big number on the left and a little number on the right, that's greater than. And then we also have the less than symbol, which has the small number on the left and the greater number on the right. These also have the greater than or equal to equivalencies over here. Some other things we should be aware of is the is equal to. That is given by equals equals, and we also have the not equals to, which is the exclamation point and equals. A common theme in Python is that the exclamation point means not. I'll also point out that the double equal sign should not be confused with the single equal sign. The single equal sign is used to assign some value. So if you want to say x equals 1, you would use a single equals, whereas the double equal sign is going to ask the question, are these two things equal? Notice that all these expressions will give back a Boolean response, that is true or false, which brings us to true and false, otherwise known as the Boolean values. So the only two Boolean values there are true and false. And so we would like to be able to have those values in our expression language, which in fact Python allows us to do. In Boolean logic, there are a few things we would also need to take into account. So if we say some set A and some set B with and in between, we're asking the question, what are the points that are common to both? If we say A or B, we are talking about the points that are encompassed either by A or B. It could also be the ones that are encompassed by both of them, but it would be a valid answer if they were encompassed by either A or B. And A not B will exclude this part in the middle. B not A would it would do just the opposite. It would fill in just this B semicircular part here, and it would exclude this part here. So basically, the not will always exclude the overlap portion. These have these terms up here: negation for not, conjunction for and disjunction for or. And those are the corresponding pictures for those terms. Now, getting back to the division, you might be a bit puzzled as to how come we have two different kinds of divisions. What's all this about floating point and floor division? So floating point division is most likely what you're thinking of when we mention division. This is the kind of division where you have some decimal and so on. Okay, so just to remind you, these are the terms. We have the dividend and the divisor. This is the division symbol here, and the quotient is the answer. So well, this is how I learned how to do division. I'm aware there are some other notations in some other schools, but basically what you do here is you just write the number above the value if it goes in. So for example, we ask how many times does 4 go into 6, and the answer would be 1. You do 1 times 4, which is 4, and then you would subtract that out to get a remainder of 2, and you bring down the next place 9, and you continue just like this, and notice we have a remainder of 0. So this is basically the regular division. The result will always be reported as a float. So for example, 692 divided by 4, which is being represented by this over here, would be represented as 173.0. So this indicates there is no remainder. And so normally, well, if you've done significant figures, you would be perhaps a bit puzzled here to say, well, you know, we really don't need this 0.0. And that's true from that point of view. And so, and in fact, actually, you may claim there's only one significant figure here, and the answer should be 200. But in any case, this is how Python is going to do things for you. It will do this division, and it will always report a point something. So if there's no decimal, it will fill in 0. And this is part of the clue that we are doing the division in the floating point style. Okay, and here's another example, 128 divided by 5, and this is showing 25.6, which is more or less probably as you would expect. On the double division symbol, this is meaning floor division, is going to tell the whole number part of the quotient. So recall you may have done some division where you first learned out how to figure out how many whole times something fit inside a number, and then perhaps you wrote remainder over here like this. So this R stands for remainder, and then there was 3 left over when we did our subtractions. So we got 25 remainder 3. So when you do the floor division, what that's going to do is it's going to return back only the whole number part. So the answer to this would be the 25. So let's just take a look at a couple examples of Python actually doing this. So if we say 692 floor division 4, recall that there were no remainders and the answer was 173. It's going to report this as 173, which is contrasted with the one showing the decimal point. Now here we have 128 divided by 5. So unlike the first example here, this one will in fact have a remainder, but it is going to report only the 25 because floor division is only going to report the whole number portion. So that's the major difference between the floating point division and the floor division, that it will tell you either decimal part or not, and that the floating point division is going to have a decimal point explicitly provided every time, whereas the floor division will not show you any decimal component ever. It will return an integer. Suppose you wanted to get the remainder, though. You might say, well, I mean, I really would like to, let's turn on the light here. I'd really like to get the remainder out of doing this problem. So how can I do that? So that's what the percent operator is for. The percent operator is going to report the remainder portion of your quotient. So going back to our same problems, we can do 692 divided by 4, which went in evenly. So that will report back 0, and 128 divided by 5. Remember that our remainder was 3, so it will report the remainder here. So the answer to a division problem can be expressed using remainders by using both the floor division and the percent operator. So this is an example of how you could print that out. So you do print 128 divided by 5 equals, and then we're going to actually calculate that, and then remainder, and then we use the calculation here. Note that we're using floor division here, and here we're using the percent symbol to get the remainder. And what we'll print out is a statement here. I know we haven't covered print yet, but I think this is hopefully fairly straightforward to follow what's happening here. So we will see more print coming up, but that is how you can print out the answer to an expression. The percent operator is useful to test for divisibility, and keep your thinking caps on because that may come up in a later lecture. The percent operator can be used to tell if something is divisible by some particular number. And the way we would do that is we would look for a problem that's going to return 0, right? So if we want to know, is 100 divisible by 2, we can figure out whether the remainder is going to be 0 or not. So if 100 remainder 2 is 0, then it means it's divisible by 2. And if you do 101, which is not divisible by 2, you will get a 1 for your remainder. So your remainder is non-zero, and therefore it is not divisible. All right, so that was our discussion of the basic functions. Let us talk about the Python types. We've kind of been visiting these anyways, but I just wanted to take a moment to really just focus on these for the moment. So what is a Python type? So different types of data have different attributes associated with them. It's useful to have different types, each with their own associated actions. And this is part of the object-oriented approach to programming, which is inherent in Python. You may have heard of Python being an object-oriented programming language, and that is part of what we're talking about right here. So consider storing dog and 3.14. Dog, being in quotes, is text, and another is a decimal number. Does it make sense perhaps to have different kinds of variables to store these different things? Would you think maybe you'd want to do different things with a piece of text versus working with 3.14? Of course. So Python is really well set up to do these various things. So for example, think about what kinds of data might you want to store. Could you think of another kind of data, and what kind of actions might be associated with each type? Well, doing addition comes to mind for 3.14. Maybe I want to add it. Maybe I'd like to multiply it. But would I really want to add dog? Well, I wonder what that would really mean. Or what if I wanted to multiply dog? Well, that seems like a bit of an odd thing to do. I wonder what that could mean. So a more formal introduction. Types are going to classify expressions. The type of an expression is always the same as the type of its value. Some types we will encounter today are the integers, floats, strings, otherwise known as text, and Booleans. Several of these we have already visited. So suppose you want to know what something's type is. Well, Python can tell you, and you can do it just like this. Now, what we see here is we have the word type, and then we have some parentheses, and we would put an expression inside. Now, this right here should be typed on the keyboard without the angle brackets, but the round brackets are part of what you need to actually type in. So for example, if we do type of 3, this will tell us that this is an integer. Type of 3.14 will tell us it's a float. Now, how do we know? Well, this one doesn't have any decimal value and this one does. Next, we're going to do type of this cell phone in quotes, and it tells us it's a string or text. And we also do type of true. This is a Boolean, and it tells us it is class bool. Strings are sequences of characters, otherwise known as text. To enter a string, you need to be sure to surround it with the single quotes. You can use the double quotes as well. Doesn't really matter which ones you use. You do need to make sure that they are the same kinds. You can't mix and match like one single quote with a double quote. So here we have two strings, hi and how's it going? Strings have the type str. Integers, just as in math, are numbers with no decimal or fraction part. It includes a set from negative infinity to positive infinity of the integers, negative and positive and 0. Integers have type int. Floats. So we've seen the floats in our attempt to do some division. So the floating point numbers are the variable precision, decimal approximation. They have type float. Python uses the decimal point to indicate the number is a float rather than an int. So for example, this one, this repeating decimal, this one is going to be a float. And if it did not have a decimal part on the end, it would be an int. Alrighty, so now it is your turn to try out a couple of problems. So if you're watching this video, as I presume you are, since I'm recording a video right now, I would suggest that you take a moment to pause the video and try these problems. And we hope to see you back momentarily. All right, well, hello. I hope you had a chance to look over this exercise. Let us talk about this. So in the first question, we are considering 3 versus 3.0. Which one's the integer and which one's a float? I bet you got that one right, knowing that the 0.0 makes this one right here be the float, and this one with no decimal part being the int. Which expressions will have different type than its constituents, and what is the value of the expression? I'm actually going to go ahead and just put this up for you here because I've made this convenient little chart here. Here is our first number. I've also included all of the types in here for you. So again, we just follow whether or not it's got a decimal, and also for the second number here. And then we take a look to see if the answer is going to be of a different type than its the parts that were given in the question. So 5 and 2 gives 2, 7 and 5 are both ints, but notice we are doing division, and division always gives a float, even if there's no decimal part. Division always gives a float. And we see that a bit of a trick right here, right? So we have 16.0, 4.0, we are doing regular division, we get 4.0, so that's float. And now, tricky, we have two ints, 16 divided by 4. Oh, the answer is 4, right? Should be an int though, because there's no decimal part. It goes in evenly 4 times, right, Professor Fair? Right? Don't be fooled, okay? Don't be fooled. Division always gives a float. The reason why it always gives a float is because it is the only one of these operations we've been talking about that you cannot know from looking at the numbers that you put in whether or not you're going to need a decimal value. So think about it. If you're going to do an addition problem and you have 2 plus 3, you know that there's no decimal part, so there'll be no decimal in the answer. Now, if you did 2.0 plus 3, you know you're going to need to add a decimal just in case, right? Because you have a decimal component now. But the thing with the division is that just looking at the numbers for the input, the 16 and the 4, you don't know until you've actually done the division to know whether it will go in evenly or not. And that's why it always just goes to a float. Booleans. So Booleans have the value true or false, and the symbols we've already met. And so here's a couple of expressions which we can then say in words. 2 is less than or equal to 3, and the Boolean value would be true. Notice that the Boolean values always begin with a capital letter and that they do not have quotes around them. If you put quotes around the Boolean values, then they will become a string. So don't do that because it will not work as expected. It will work like a string. And also you need to remember to capitalize because capitalization matters. This is the Boolean truth table. So basically what we're trying to say is, okay, if you have something and something else, does this yield a true or a false value? So I like to think of the cookie jar example. So imagine a little kid, maybe it's you as yourself in your former years when you loved to eat cookies. And the babysitter comes in and says, Kelly, did you eat that cookie out of the cookie jar? And maybe I'd say in my little toddler voice, yes, but the aliens made me do it. And do you think that's really a true statement? Have I really told the truth if I said that? I said something that was true. I said, yes, I ate it. But I also made up a story that was false. So overall, I really haven't told the truth. The only way you're really telling the truth is if you tell the whole truth, right? If true and true is the only way you can get true. It is true and false or false and true. No, I didn't eat the cookie. That's not true, right? It doesn't matter what else I say. I've said something that's not true. And then, of course, if you tell two tales, then it's still false. This is the Boolean truth table. We're asking if you have something and something else, whether or not we're getting true. So these are the Python types we've seen so far. We've seen strings, integers, floats, and Booleans. This is how they will be written: str, int, float, and bool. And here's a little example of each one. And we will learn more types throughout the course. Types are, in fact, an integral part of the Python programming language. Well, let's next consider the compound expressions. So compound expressions may involve expressions of different types. When the expression is evaluated to its value, the type of the value will depend on the types in the expression, and the expressions are parsed using the order of operations. So we can check the type of compound expressions using the type, just like we have used before. So for example, if we have some expression 3 plus 4, you can do type, open parentheses, and instead of just putting a single thing in there, you can put the whole expression 3 plus 4 right there. And it tells us that it's class int because the answer 3 plus 4 is the integer 7, which is class int. Now let's do a harder one, type of 4 minus 2.6. This one's got a decimal value. So the answer is going to have to be a float. So this will tell us class float. And here is type of 2 is less than 3. This will give us a true or false answer, which is a Boolean, and we get class bool. So then let us have a summary of what we have talked about today. We've talked about expressions and values. We have talked about a number of Python types. We've also talked about statements and parsing the expressions. So looking ahead, what you should do is try your problem set number 1. You can do that either with us or you can do that on your own. That is up to you. I'm happy to work with you during the during the problem solving to help you go over those. Please do post your solutions to Moodle so that I can give you some feedback. Again, remember that this is a mini course and there is no grade to it, so there is no need to be panicking about grades. This is just for fun and to get a sense of what the real class is going to be like. So I do encourage you to do the problem sets, and I hope that we will see you coming up in the lab. Enjoy your day, and certainly feel free to reach out to me if anything comes to mind that you would like to ask me. We are here for you. Talk to you soon. Bye-bye.